Hikers 1 regenerative receiver using a type 49 valve in space charge mode. I'll run through the medium wave band and then talk about the interesting design of this.
Growth, its quarterly is 25% higher. The potential to reacquire that capability as a significant questions about the integrity of the process.
He mentioned in the State of the Union Iran's nuclear.
What is happening back in Oz? 131873 is the number. 0460873873 is the text line. We've got plenty coming your way. Hard to win lumens, Lenny.
Their name in, not follow us. Check it out.
Across 39 states in the US. The solar installations ranged from 1 to 328 megawatts in capacity and averaged 400 acres in size, with the large.
Okay, here's the circuit in the constructional article for the Hikers 1, and I've put a link in the description to the website article. It's a conventional regenerative receiver except for one thing. If you look closely here, you can see that the connections to the grids appear to be reversed, which they are, because the valve type 49 is being used in space charge mode, and what that means, it's a way of getting sufficient current to flow at very low voltage so that the valve will function. And in this case, the B plus is only 9 volts. And in very simple terms, the way the space charge mode works is if you positively bias the first grid, you'll get enough electron flow that some of the electrons actually reach the plate, and what would normally be a screen grid actually functions as the control grid. Now the 49 is a special valve. It's not actually a tetrode as such, it's what's called a dual grid valve, and it was intended as a class B audio output valve, 2 of them in push-pull, for battery receivers. But yeah, I'd sort of talk about that in the website article. Aside from that, it's quite conventional. You've got your aerial coming into a primary winding, and then you've got your grid winding, which is tuned with the variable condenser in the normal way. The normal grid lead components, 100 picofarad and 1 meg, and the feedback in the plate circuit. It uses the dreaded shunt resistor method of regeneration control, which I'm not a fan of, but that's what we've got. The coil is standard, 35 turns for the feedback winding, 100 turns for the tuned winding, and 40 turns for the aerial. So this article came from the Lamp House Annual in 1939, which is a There was an electrical store in Wellington, New Zealand, which sort of popularised this circuit. It was originally presented as a constructional article in Popular Mechanics in 1936, and prior to that it first appeared in 1935 in QST as a shortwave receiver. So we'll have a closer look at the receiver now. First thing you're probably wondering is, what were you actually listening to? Well, this being a headphone receiver, so that you could hear it, I've got it running through my bench amplifier. And people have asked about this before. All it is a single valve amplifier using a 6M5 and a 6X4 rectifier, and that is being fed using an audio transformer as a load instead of the headphones to maintain the DC continuity and to form an AC impedance. I can actually plug in a set of headphones to the other side of this transformer. Now, coming around to the back of the set, you'll notice the 2.2k resistor I have clipped across the potentiometer, because the potentiometer is way too high of a value. It should be down around 2.5k, so I find that putting the resistor across it makes the regeneration a lot easier to adjust. And if I was to put this receiver into regular use, I would actually change the pot. It is actually a switch pot, which makes it even more difficult to replace. Switch pots are something out of fashion these days and not easy to get. Okay, now the batteries I'm using, there's 1.5 volts for the heater, there's 6 volts for the high tension, and there's a 3.7 volt lithium battery for the bias. Now, unlike what Lamp House have suggested, their so-called improved circuit is anything but, because 1.5 volts is just completely inadequate, especially with the 9 volt high tension. I found that the bias voltage should be roughly half. So for 9 volts it should be about 4.5. So that's why I'm using 3.7 on 6 volts. And conversely, if you're using 12 volts, about 6 volts works well. There's actually not a lot of variation in volume between the different values of high tension. So 6 volts is a good all-round figure, and with that you only need 4 cells for the high tension and tap the bias off at 3 volts, and then of course 1.5 volts for the 49 heater, and that's the 49 itself. I don't know if I can zoom in on the grids on that, probably not. But otherwise it's a conventional sort of baseboard construction. It works very similarly to the 1Q5 receiver, which I made a video of before. If anything, I would say the 1Q5 receiver does work better given a choice, but there's not a huge difference. Otherwise, yeah, look, it's an attractive, and it's quite a novel receiver using the old space charge technique. And just on that subject, whenever you mention space charge, people say, oh, the 12 volt car radios of the 1950s were full of space charge valves. With the exception of the valve that drove the output transistor, the other valves were all conventional. They were not space charge valves, and that's something which everyone seems to overlook. So there it is, the 1938 Hikers 1.